All right, now let us move to the last memory part, which is semantic store. Okay, firstly let us understand what is semantic memory. So semantic memory stores essential facts and other information that ground an agent's response. Okay, so if I look at semantic memory, when will I be using semantic memory? Semantic memory is typically used when I want to work with facts and knowledge, when I want to work with user preferences, when I typically when I'm working with facts and knowledge kind of data, I'll be using semantic memory. Okay, as simple as that, nothing else. Okay, so what is our semantic store going to do here? It is going to manage the sponsor knowledge base. Now what is sponsor knowledge base? Sponsor is someone who funds the research, who's doing the research. For example, Pfizer is doing the research, Novo Nordisk is doing the research, Reckitt Benckiser is doing the research. That becomes your sponsor. And this sponsor knowledge base is nothing but the growing collection of facts about every research sponsor that has ever encountered, right? So what is semantic memory? You can just think of this like a credit rating agency like CIBIL in India or Experian in US. Okay, every time you take a loan or miss a payment, your credit score changes and the agency builds up your profile basis the financial behavior over the years of transactions. So similarly, we want that agent, the facts related to that agent and the work associated with it, we want it to update and basically change every single time. It should be dynamic in nature, and that is what semantic memory comes into picture. And this is where what semantic memory does here for sponsors. Every time my agentic pipeline analyzes a research study, it updates the sponsor profile. For example, did they post the results on time? If yes, credibility goes up. Did they miss out on the results? Credibility goes down. Did they switch the outcomes? Broken promises count goes up. Did they delay the trial silently? The average delay goes up. Okay, so every single time some data is getting constantly updated dynamically, and that is where semantic memory comes into picture, right? So semantic is what? It is going to be facts about the world, accumulated knowledge. It's like encyclopedia. For example, Novo Nordisk has 47 research studies. The credibility is 0.82, which is 82%, but it has 2 broken promises, right? So where sponsor profiles are stored? In an existing sponsor profiles table in the Cloud SQL. Now, in Cloud SQL, you also need to run this command. Okay, so you just have to run this command, which is, now we already have one table called as sponsor profiles, which have roughly these columns. Okay, so you can see here it has something called as credibility score, total studies, results posted, average delays, broken promises, all of that. Okay, so here we are going to add the missing column that we have added in semantic. Now in semantic store, we're just going to add a missing column. We're just going to add it here, which is results missing. Okay, now just make sure that you have added them. Just make sure that you run this statement once. Okay, add a column, if not exists, results missing. Now here, because I've already run the column is already there, but in your case, if it's not there, just make sure that you run this once. Okay, and after running that, just confirm that the full table has correct structure to be followed. So if I just take, so these are all the columns, okay, in the sponsor profiles tables that should be there. So just make sure that you also add the in sponsor profiles table, just make sure that you add this column, which is results missing. Okay, fantastic. All right. Okay, so now will we be running this file directly? Obviously not. Our agents are going to will be importing these memories. We start with standard imports. All these standard imports we already know. We start with creating a class called as semantic store. What does this class do? This manages the sponsor knowledge base, which is the credibility profiles, which are built over time by the agentic runs. Okay, each sponsor gets one profile row in the sponsor profiles table. That row is updated, never replaced. So every time new information about the sponsored can be discovered. Okay, you can think of this like a living document about each sponsor. It grows richer with every analysis. Okay, this is how we're going to use it. We start with the constructor function. We look out for the pool. We just create a connection pool. As of now, it is going to be set to none. We're just going to say that semantic store is initialized. Then we just check if the if the connection is created, if it exists or not. When we create the connection, we're going to take all these things into consideration. Once the pool is created, we're just going to say that the semantic pool has been created. I'm just walking through because we have done this multiple times now. Okay. Then I'm going to create an async function called get sponsor profile. From the name itself, you can understand it gets the name of the sponsor. Who is the sponsor? For example, Novo Nordisk. Okay, but it takes the entire profile, like gets the profile. For that, first and foremost, we need to take the sponsor into consideration. Then what does it give in the output? It gives us a dictionary. That it returns a dictionary if a sponsor exists in the database. If not, it returns none. Okay, so it retrieves everything about a specific sponsor. What does it retrieve? What is the sponsor name? What is the credibility score? How many total studies? How many have they posted the results on time? Are there any missing results? Are there any broken promises? Are there any average delays? What are the last updated? All of that it gives. How is credibility score calculated? It's a simple average. Okay, so 70% results compliance rate posted divided by total results. 30% promise keeping reduced per broken promise. So that is how it gives a credibility score. Okay. It is just going to check if the database connection is open. Basis that, it is going to check out one connection from the pool, and it is going to fetch. From that connection, it is going to apply fetch row. Fetch row returns one row, not a list of rows. And this is correct here because each sponsor has exactly one profile row in the sponsor profiles table. Okay. If no row exists for the sponsor, fetch row returns none. So you just created a simple, SQL script, which is just going to return us, some data here. It's just going to return us the sponsor data. Okay. All right. If row is none, it's just going to say that there is no sponsor in the first place. And finally, what does it return? It returns the sponsor, credibility score, total studies, results posted, results missing, all of this data. Okay, that we wanted. Okay, this is the dictionary that it gives in the output. Then we go to the next method, which is update sponsor knowledge. Again, it takes the name of the sponsor into consideration. Has the sponsor posted the results with respect to their research? Have they broken any promise? Which means, did we detect the outcome switching in the study? For example, it is true when the broken promises count goes up, the credibility decreases, which means they started the research at some other area, they ended up in some other area. Okay. Are there any number of delays in the research? Okay. What does this do? It updates the sponsor's profile with the new information from one study. It uses the upsert pattern. Upsert is insert. Upsert means insert if any sponsor does not exist. Update if they already do, which is fantastic, right? So PostgreSQL does one thing, does this in one statement using insert on conflict do update. Okay, there is more efficient and safer than checking first with select etc. So we're going to use this. Okay, how does the credibility score gets recalculated? So after updating the counts, we recalculate the credibility score, and this is the formula. Okay. We ensure, now these are all the arguments that we take into consideration. We make sure that the pool connection is available, and then we just execute. Like if you see insert into sponsor profiles, into the sponsor profiles tables that we have here, into the sponsor profile table, you can see in all these columns we're going to update the data. Okay, so in total studies we're going to say sponsor profiles dot total studies. Okay, we're going to add all of that. We're going to do all of that. If you see here, I've given the information. Okay, credibility score starts at 0.5, which is neutral into consideration. Total studies start at 1, and this is their first study. Okay, and every single time it basically just gets incremented, right? Every single time you have a study, that total study will get incremented, right? Results posted, add 1 if true, add 0 if false. Okay, I've given all of them here. Okay, now $2, if you see this placeholder, this results posted as integer, true equals to 1, false equals to 0. All of this, I've just given this as it is. You can just go through this. Okay, it recalculates the credibility score, all of that. Okay, now we're going to update the sponsor profile. We're going to set the credibility score. Okay, we're going to put a case when kind of function. We're going to put in a comparison. We're going to do all of that, and we're going to update the sponsor knowledge. Okay, then we get at the next function, which is low credibility sponsors. Okay, in low credibility sponsor, we're going to look at the threshold. Okay, Threshold we have set it to 0.6 by default, which means you're going to return the sponsors whose credibility score is below this particular number. Okay, which means they are not great sponsor. They are, I mean, it is considered as concerning. It is going to check for the minimum number of studies that we require before we flag a sponsor. And what does it give in the output? It gives a list of dictionary. It returns all the sponsors whose credibility is below the threshold. Okay, this particular thing is used by track record agent to quickly identify problematic sponsors, pattern finder agent, and the API endpoint, this one. Okay, all right, these are the arguments it takes into consideration, which is threshold and minimum studies, and it returns a list of sponsor profiles. Okay, all right, so you can see here from the connection it is going to fetch this data. Okay, I've written the explanation here as well. You can just go through this. We are not interested in this. We are just interested as to finally what does it give in the output. Okay, so it gives me the sponsor, credibility score, total studies, results posted, missing results, average number of delayed days, and last updated. And finally, what are we going to get with this function? We're going to get how many low credibility sponsors are there. Okay, then which is going to check if the sponsor exists or not. Just gives a simple true or false. It just checks if the sponsor profile already exists in the database, yes or no. It is just going to look at the count of those sponsor profiles. Okay, that's all. And finally we create a function which is going to close the semantic pool. Okay, you can just go through this slowly and steadily. Okay, the main item here is not to understand how SQL commands are written. It is just to understand how things are working. Okay, and what is semantic store in the first place. All right, cool. Now let's go to the tools part in the next video. Yeah, thanks.